Welcome back to a lecture series on GIS. So in this exercise, now we are going to discuss about the query analysis. So this is the most interesting analysis, advanced analysis. If you have the data, if you have plenty of data at the attribute table, like thousands and thousands of the data, maybe population, maybe for the whole India or for the whole world. If you want to play with the data, because GIS is not a map making tool, it is a map analyzing tool. And whatever the query you put, maybe you can put from the attribute point of view, so that we will get a number of results. And here what we have taken up for the present discussion is about the coastal erosion. We have a specialized team working on climate change and disaster. So in that a part of it, we have taken some samples to go further for about how query analysis are carried out in this. So in this exercise, we will see that how query analysis is executed. So it is in GIS, it is now to get the information about attribute table. That's what I said. In query, it's a question. It is a question. It is a question in GIS to get the information from attribute table using conditions. Now you're going to explain the different conditions. Like for example, classify the same data using the statement. Maybe the statement may be the data like and you can use the data or the data may be less than, more than, less than equal to, or more than equal to, etc. It's all mathematical expression. And all graphical data. There are three attribute table work. There are three work which is here. One is adding the data, second one open the graphical attribute table and split the classified values using query conditions, and third one is using this classification you can make use of it. The classification what we are now going to use it as an example, that the endpoint rate, that is the erosion in the coastal domain, where the erosion is more, that is high erosion. If it is more than -4, if it is less than -4, and -4 to 1 is low erosion, -1 to 1 is stable, and 1 to 4 is low accretion, and above 4 is high accretion. This is how the classification of we are going to have it in the query analysis. We will see that how this is going to help us. There are different ranges and different classification as what we are now going to apply using this graphical attribute query. Once if you have the data already which you have prepared, this is the transacts of coastal in the Thoothukudi region, which we have generated through DISA software. Now we are going to classify this area into different zones like low erosion, high erosion, and all. You have plenty of data. Look at the back table, that the data is huge in number. Now you are going to make a meaningful with the data, you are now going to make a meaningful information. And transacts are 1112, and EPR endpoint rate 1122. This is total number of lines which is generated through DISA software. And the endpoint rate is now we are going to use and then classify that region into high erosion, medium erosion, low erosion, stable. And you see this is the numbers are representing the erosion characteristics. If minus comes the erosion and plus comes the deposition, that is accretion, and erosion is being represented over here. Now this classification, let us take the first classification of high erosion of less than -4. I mean it means -4 and above, -5, -6, -7. Let us see how the values are going to be used by using the statements and or, and greater than, less than, or greater than, less than, equal to, etc. in the ArcGIS, I mean query output classification. Now once if you open, then but by looking the data, and now you just arrange your table in such a way that for you to to work comfortably for the query analysis. Endpoint rate is the area where we are now going to work with, and this is the table. You can bring the Excel table. You can you classify into 4 zones like high, medium, low, high erosion, low erosion, high accretion, low accretion, stable region. Yes, 2 is erosion, 2 is deposition, right? And now you classify this data by using query analysis. You have to take the table, select by attribute, and you have to select all records, not selected records. You see this is all record you take. Now select by attribute. In select by attribute, you have to take the EPR, endpoint rate, and you are now going to apply by using all these function keys. EPR, that high erosion is -4. What does it mean? -4, -5, -6. It means it is above. -7. All these are all high erosion. It means erosion is more. That's why the minus symbol. Less than 4 means it is increasing in number at the other side. Less than equal to, sorry, more than 4. So more than -4 is equal to this endpoint rate. Now you have to take EPR, select, double click. So automatically this will select the data from EPR, which is -4, right? This is the symbol used here, high erosion. Apply. It will select only from above -4. Look at this table, above -4, all EPR value. Based on this, it will copy selection and then go to the Excel file and paste it. So now you are very clear that how you are doing your buffering. I mean taking out all the information of high erosion. Here also you can check with assessing the minimum and maximum value, and you can go to auto sum and find the maximum value, enter. It is -4.1. And you also can check with the minimum value among all the data that you select up to maximum, before maximum. Select, then you will get, sorry, the data, it is reverse here. It is because of -12.42 from 4.01 to -4.1. So 12 is the data distributed of the erosion found here in the study area. And similarly you have to do it for all the other portions, and you can remove this by using the erosion, and then you have to do it for low erosion, stable, low accretion, higher accretion. So now look at that how I am doing, and you have to take the database into Excel file to check whether your data is. Now low erosion is 0.4 to 0.1. What does it mean? 0.4, 0.3, 0.2, it's all minus, and -1, only up to -1. So 0.4, -4, -3, -2. It is above, I mean less than -4 to more than -1. Point -4, -3, -2, -1. This is a less than symbol. Less than this up to -1. So EPR, you have to be careful of applying all the mathematical functions. And -4. This is how we study from -1 to -4. I mean you have to select now by applying this formula for assessing between -4 to -1 to split the classified value into using query conditions. Now you have to use and option and select Now right click again, open attribute table. Now go to selection and selection, and then select attribute, select EPR, double click, which is equal to, and -4, that is greater than -4, and here 2 you will have to use, and -1, it is above -1. EPR, here you have to type minus, greater than is equal to, it means between 1 and 4. So this logic, mathematical operations, we are in need of understanding how to give the query in GIS. Now this is the attributes are selected. You can look at the databases. It is between -1 to -4. That is endpoint rate -1 to -4. And you go to copy all this and paste it and save it. Right now this is over, and similarly paste. Now also here you just assess with the minimum maximum value whether it is be there in -1 to -4. Make it auto sum to assess this, and the minimum value should be less than -4. Maximum value should be -4. Yes, it is -3.97. Now it's correct. Now we will go to stable, and similarly we have to do it. That logarithmic applications we have to be very careful. I'm just erasing the portion what I have written. For understanding of query studies. Now we'll go to stable. Yes, first we have to unselect all the files, clear all the files. Otherwise it will work only with the selection area. EPR is equal to -1 and +1. Right, apply. -1 to +1, apply. Now the data between this is selected. Copy all the data and paste it in the stable bar in Excel file. You also can check with your databases of assessing the minimum and maximum. And the minimum, yes, it is between -0.099 to +0.099. And similarly we have to do it, and more than 1, greater than 1 to less than 4 for low accretion. more than 4 and greater than 1, that is correct. Apply. Yeah, greater than 4 and less than 4, greater than 1, less than 4. Apply. Now the data is selected, copy it all the data. So this is the low accretion zone, and here also you have to check with the minimum value, maximum value of your EPR. So it is between 1.01 to 3.99. Now we have to go to the higher accretion, more than 4. So you have to clear the data selection and select by attributes. You will have to now add a EPR is more than 4, greater than 4. So this is very simple. Above 4 is now going to calculate 4, 5, 6, and the higher zones are going to calculate. Yes, now the symbol is reverse, sorry. So now you copy everything and then paste it with the higher accretion zone and check the minimum maximum data for your assessment. Yeah, it is maximum will be there above 420, but this will be there, it should be less than 4. 4, yeah, it started after 4 only. Yes, it is correct. So this is how query analysis is being carried out in GIS, and you can do plenty of operations by using this because many combinations are there, like and, or, greater than, more than. Now we have explained with this data. With this, the query analysis in GIS is come to an end. How to do it in ArcGIS. With this, it is come to an end. I thank you.